On February 28, 2026, the United States unleashed the most diverse weapons arsenal in modern history against a single nation. B-2 stealth bombers that first flew before the fall of the Berlin Wall, Tomahawk cruise missiles designed during the Cold War, F-35 Lightning IIs carrying weapons that didn't exist 5 years ago, THAAD interceptors burning through inventory at $12.7 million per shot, and for the first time in combat, Lucas drones. $35,000 copies of Iran's own Shahed design, reverse-engineered and sent back at the nation that invented them. More than 20 distinct weapons systems. 3 decades of American military evolution concentrated into a single operation. Some of these weapons were designed to fight the Soviet Union. Some were designed last year. One was copied from the enemy it's now being used against. Together, they represent the complete transformation of how the United States fights. From the first Tomahawk strikes of 1991 to the AI-coordinated battlespace of March 2026. This is the story of every major weapon being used in Operation Epic Fury. How each one was born, how each one evolved, and why this specific combination reveals more about the future of warfare than any single system ever could. 35 years before Epic Fury, the United States fought its first modern air war. Operation Desert Storm, January 17, 1991. The opening salvo was not a bomb dropped from a plane. It was a cruise missile launched from a warship in the Persian Gulf, flying at 500 miles per hour, 50 feet above the desert floor, navigating by matching terrain beneath it to digital maps stored in its guidance computer. It flew for over an hour without any human input. Then it hit a building in downtown Baghdad, within 3 meters of its programmed target. The weapon was the BGM-109 Tomahawk. And in January 1991, most of the world had never seen anything like it. The Tomahawk was born in the late 1970s as a Cold War weapon designed to carry nuclear warheads deep into Soviet territory. 20 feet long, 2,900 pounds at launch, powered by a small Williams F-107 turbofan engine, producing just 600 pounds of thrust. Range, over 1,000 miles. It flew so low that ground-based radar couldn't see it until it was already past. And because it launched from submarines and surface ships, it could strike from any ocean on Earth without risking a single pilot. In Desert Storm, 288 Tomahawks were fired. They struck command bunkers, communications nodes, power stations, and air defense sites across Iraq. The accuracy was unprecedented. The psychological impact was greater. For the first time, a nation watched on live television as unmanned weapons destroyed targets in a capital city with surgical precision. Cost per unit, roughly $1.5 million. Expensive by missile standards, but a fraction of the cost of losing a crewed aircraft. But the 1991 Tomahawk had a flaw that wouldn't be fully exposed for years. Its terrain-matching guidance, called TERCOM, required detailed maps that took weeks to program. It couldn't hit targets in flat, featureless desert. It couldn't be retargeted after launch. It couldn't adapt to moving targets. The Tomahawk of 1991 was a brilliant weapon aimed at a fixed world. The world was about to become far less fixed. And there was another vulnerability the Tomahawk couldn't solve, one that no cruise missile could. A new class of threat was emerging that ship-based radars couldn't track and traditional interceptors couldn't catch. A threat so cheap and so slow that the most expensive naval fleet in history had no efficient answer for it. That vulnerability would remain exposed for 3 decades, until March 2026, when the most unlikely weapon in the American arsenal finally closed the gap. The evolution of the Tomahawk across 3 decades mirrors the evolution of warfare itself, and the version flying over Iran in March 2026 shares almost nothing with the missile that struck Baghdad 35 years ago. This level of analysis, tracing each weapon from origin to combat deployment, exists nowhere else. Exodus maps the transformation of power in real time. Subscribe to monitor the complete chronology. The next evolution is already classified. The Tomahawk Block 4, deployed starting in 2004, added something revolutionary: a 2-way satellite data link. For the first time, a Tomahawk could be retargeted in flight. A missile launched at one set of coordinates could be redirected to a completely different target hundreds of miles away while already airborne. It could loiter for hours, circling, waiting, then strike on command. The one-way bullet of 1991 had become a controllable weapon that could wait in mid-flight. The Block 5 variant, entering service in the early 2020s, added maritime strike capability. A Tomahawk that could hit a moving ship at sea, tracking its target through radar and infrared sensors in the terminal phase. Range, over 1,000 miles. Cost per unit, approximately $2 million. In Operation Epic Fury, Block 5 Tomahawks are being launched from Arleigh Burke-class destroyers and Virginia-class submarines across the Persian Gulf, the Arabian Sea, and the Red Sea. The same class of weapon that opened Desert Storm is still opening the battle 35 years later. Upgraded, evolved, transformed, but recognizably the same missile. A weapon designed to carry nuclear warheads into the Soviet Union in 1980, now carrying conventional warheads into Iran in 2026. 46 years of continuous evolution. No other cruise missile in history has served longer or struck more targets. But Tomahawks cannot operate alone. They fly at subsonic speeds, roughly 550 miles per hour. Against modern integrated air defenses, a Tomahawk is detectable, shootable, killable. To reach their targets, Tomahawks need something to go in first, something that air defenses cannot see. The B-2 Spirit, the most expensive aircraft ever built. Unit cost, $2.1 billion in 1997, roughly $4 billion in 2026 dollars. Wingspan, 172 feet. Weight, 170,000 pounds fully loaded. Range, over 6,000 miles without refueling. Crew, 2 pilots. Radar cross-section, less than 0.1 square meters, roughly the signature of a large bird. A 170,000-pound aircraft that appears on radar as a Pigeon. The B-2 first saw combat over Kosovo in 1999. It flew 30-hour round-trip missions from Missouri to Belgrade and back. Each aircraft carried 16 2,000-pound GPS-guided bombs. Serbian air defenses, dense, sophisticated, actively hunting, never detected a single B-2. In Epic Fury, B-2s are flying against hardened and deeply buried targets in Iran. Underground nuclear facilities buried under mountains and reinforced with hundreds of feet of rock and concrete. The B-2 is the only platform certified to deliver the GBU-57 massive ordnance penetrator. 30,000 pounds, 20 feet long, designed to penetrate 200 feet of hardened concrete before detonating. Each B-2 carries 2. Only 21 were ever built. Approximately 19 remain operational. The entire deep strike capability of the United States rests on fewer aircraft than a regional airline operates. There is a reason only 19 exist. The Air Force planned to buy 132. The end of the Cold War collapsed the justification. Congress cut the order to 21. Each surviving aircraft has been maintained and upgraded continuously for over 30 years. Avionics updated 5 times. Stealth coatings reformulated 3 times. Original mission computers, built before the internet existed, replaced entirely. The B-2 over Iran in 2026 shares its shape with the aircraft that rolled out of a Northrop hangar in 1988. Almost nothing else is the same. A ship of Theseus at $4 billion, rebuilt so many times the original barely exists inside it. 19 aircraft, $4 billion each. 60,000-pound bomb loads into airspace no other aircraft on Earth can enter undetected. The margin between strategic capability and strategic vulnerability has never been thinner. Understanding why that margin matters and what fills it requires the kind of analysis that surfaces nowhere else. Exodus doesn't just report the evolution of power, it decodes the trajectory. Subscribe to secure your position inside the chronology. What comes next will redefine the arsenal, but stealth bombers operate in a domain measured in hours. Epic Fury also requires dominance measured in seconds. That domain belongs to the fighter. The F-35A Lightning II, the most expensive weapons program in human history. Total program cost through 2026, over $1.7 trillion. Unit cost, approximately $80 million. Single engine, single seat, top speed, Mach 1.6, notably slower than the F-15 Eagle it partially replaces. The F-35 was never designed to be the fastest fighter. It was designed to be the most aware. Its AN/APG-81 AESA radar tracks hundreds of targets simultaneously beyond 150 miles. Its distributed aperture system, 6 infrared cameras embedded across the airframe, projects a 360-degree view directly onto the helmet visor. The pilot can look through the floor and see the ground below. Its electronic warfare suite jams radar, spoofs missile seekers, and intercepts communications simultaneously, automatically, without pilot input. In Epic Fury, F-35. As are doing something impossible for any previous fighter, acting as airborne command nodes. An F-35 at 45,000 feet detects an Iranian missile battery at 200 miles, classifies it, generates a targeting solution, and transmits it to a Navy destroyer that fires a Tomahawk, within seconds, without the F-35 firing a single weapon. The fighter has become a sensor, a decision maker, a quarterback. Alongside the F-35, the F-15E Strike Eagle, first flight 1986, conducts strike missions carrying JDAMs and AIM-120 AMR AAMs. The F-15E carries 23,000 pounds of ordnance, nearly 3 times the F-35's payload, faster, heavier, at 30 million per unit, less than half the cost, 40 years old, still lethal. The evolution of air combat does not always retire its predecessors. Sometimes it finds them a different job. But the F-35 is not the most dangerous weapon over Iranian airspace. The most dangerous weapon is the one the United States didn't invent. The one it stole. The MQ-9 Reaper, 66 feet long, 27 hours of endurance, 3,800 pounds of payload. In previous wars, the Reaper was the hunter killer, orbiting for hours, firing hellfires at individual targets. In Epic Fury, its role has shifted. The Reaper is now a sentinel, cameras and radar feeding targeting data to other systems. It watches. The Tomahawk kills. The F-35 coordinates. The hunter killer has become an eye, still vital, no longer the star. Because the star of this war costs less than a luxury sedan. Lucas, low-cost unmanned aerial system, Delta Wing, GPS-guided, one-way attack drone, wingspan, 8 feet, weight, under 200 pounds, warhead, 40 pounds of explosive, range, over 1,500 miles, cost, $35,000. Design derived directly from reverse engineering the Iranian Shahed 136, the same drone Iran supplied to Russia against Ukraine. The same drone Houthi forces launched at commercial shipping in the Red Sea. The United States studied Shahed wreckage recovered from Ukrainian battlefields, analyzed the aerodynamics, deconstructed the guidance, reverse engineered the engine. Then American engineers improved every component: GPS accuracy, ignition reliability, manufacturing consistency, and produced them at industrial scale. In March 2026, Lucas drones are launched in waves against Iranian air defense positions, radar installations, and command nodes. Each drone, $35,000. Each interceptor missile fired to stop one, $500,000 to $3 million. The attacker wins the exchange even when every drone is destroyed. Iran is watching its own weapon, refined, perfected, mass-produced by the nation with the deepest manufacturing base on Earth, fly back at the forces that invented it. The technological humiliation is total. The cost asymmetry is devastating, and the strategic message is unmistakable. The era of expensive weapons monopolizing the battlefield is over. The weapon you can afford to lose in the thousands will always exhaust the weapon that costs millions to replace. Lucas represents a philosophical revolution in Pentagon procurement. For decades, every American weapon pursued maximum capability at maximum cost. F-35, $80 million, B-2, $4 billion. Tomahawk, $2 million. Lucas inverts the logic entirely. Minimum capability, minimum cost. Not designed to survive. Designed to impose cost on the enemy by being cheaper than any possible defense. The weapon's destruction is the strategy. And Lucas closes the gap that the Tomahawk left open for 30 years. The vulnerability that ship-based radars couldn't solve, cheap, slow, expendable threats saturating defenses through volume, is now a weapon in American hands, not just a threat against them. The nation that spent 3 decades trying to defend against low-cost drones has become the nation launching them. The weapons shaping March 2026 are not random. They are the output of 3 decades of evolution converging on a single battlefield. Those who track that convergence hold the map to what comes next. Those who don't are navigating blind. Exodus is the map. Subscribe before the next transformation renders today's arsenal obsolete. On the defensive side of Epic Fury, the systems protecting American forces are hemorrhaging interceptors at rates never seen in modern warfare. The Patriot PAC-3, 302 kilograms, Mach 5, pure kinetic kill, no explosive warhead. Each round, $4 to $6 million. Patriot batteries defend U.S. air bases across the Gulf from Iranian ballistic and cruise missiles. In the first 2 weeks of Epic Fury, multiple batteries fired more interceptors than were used in the entire Gulf War. Raytheon produces roughly 500 PAC-3 missiles per year. Consumption is outpacing production. The shield is thinning with every successful intercept. THAAD, Terminal High Altitude Area Defense, 20 feet long, Mach 8.2. Intercepts at 150 kilometers altitude. 17 for 17 in testing. Each interceptor, $12.7 million. Fewer than 500 in estimated total inventory. THAAD batteries across the Middle East are engaging Iranian medium-range ballistic missiles, too high and too fast for Patriot. Each kill is a technical triumph and a financial hemorrhage. Iran's missiles cost a fraction of the interceptors destroying them. The arsenal is bleeding out, not from defeat, from success. Every interception is a small strategic victory for the attacker. The Pentagon calls this a cost-imposition strategy. Iran doesn't need to penetrate the shield. Iran just needs to make the shield too expensive to sustain. At $12.7 million per THAAD round versus a few $100,000 per Iranian ballistic missile, the math is a slow-motion financial siege. The interceptor stockpile is finite. The production lines are maxed. And Tehran knows it. This is the cost-imposition crisis. Not theory, not projection. Happening now, in real time, in March 2026. The most advanced missile defense systems ever built are succeeding themselves into obsolescence. But the crisis has a counterweight, and it is already on the battlefield. The AN/TWQ-1 Avenger, short-range air defense mounted on a Humvee, has been upgraded with experimental directed energy prototypes. Pentagon briefings in early 2026 confirmed deployment of high-energy laser systems to the Middle East. Designed to destroy exactly the targets draining interceptor stocks, cheap drones, slow cruise missiles, unguided rockets, cost per shot $10 to $50. No ammunition, no magazine, limited only by electrical power. The laser doesn't replace the Patriot. It protects the Patriot. By eliminating low-value targets that would waste million-dollar interceptors, directed energy preserves the kinetic stockpile for threats only kinetic weapons can kill. Each threat matched to the cheapest weapon capable of destroying it. The logic of cost imposition, reversed. The bleeding, staunched. On the ground, HIMARS, the high-mobility artillery rocket system. GPS-guided rockets at 50 miles. ATACMS ballistic missiles at 190 miles. 6 rockets per launcher. Reload, 5 minutes. Each launcher fits inside a C-130. HIMARS became globally famous in Ukraine, where it shattered Russian logistics networks with surgical precision. In epic fury, HIMARS units are striking Iranian proxy positions and forward installations across Iraq and Syria. But this is not just artillery. This is the executioner of logistics, the weapon that doesn't kill armies, it starves them. Ammunition depots, fuel reserves, command nodes. The supplies that keep a military breathing eliminated one GPS-guided rocket at a time from a truck that relocates before the debris settles. Shoot and move. The oldest artillery doctrine in history, executed with satellite precision at 200 kilometers. And beneath all of it, beneath the bombers, the fighters, the drones, the missiles, the lasers, a predator that has operated in absolute silence for decades. The Virginia-class nuclear attack submarine, USS Virginia, 377 feet long, 7,900 tons submerged, over 25 knots underwater. Diving depth, classified, estimated beyond 800 feet. Crew, 132. Cost, $3.4 billion per hull. 12 Tomahawk cruise missiles in vertical launch tubes. 4 torpedo tubes carrying Mark 48 heavyweight torpedoes. 3,500 pounds each, capable of destroying any vessel afloat. The apex predator of the deep, invisible, patient, lethal beyond anything on the surface. Virginia-class submarines are almost certainly operating in the Persian Gulf and Arabian Sea during epic fury. Launching Tomahawk strikes from positions Iran cannot detect, cannot target, cannot counter. A Virginia-class fires 12 cruise missiles, repositions at 25 knots underwater, and is 100 miles away before the first warhead reaches its target, functionally invulnerable to anything in Iran's arsenal. It strikes without being seen. It moves without being heard. The ultimate ace, played from beneath the surface, where no radar reaches and no satellite tracks. The convergence of all these systems, Tomahawks from submarines, B-2s dropping bunker busters, F-35s commanding the battle space, Reapers feeding sensor data, Lucas drones saturating air defenses, Patriot and THAAD intercepting incoming missiles, HIMARS executing logistics, directed energy lasers preserving the shield, represents something unprecedented in the history of warfare. Not combined arms, integrated evolution. 35 years of parallel weapons development, fielded simultaneously, each system covering the weaknesses of the others. The 1991 Gulf War used these systems in isolation. Tomahawk struck first, then aircraft, then ground forces. Sequential, linear. Epic fury is simultaneous, parallel, networked. A B-2 drops a bunker buster, while an F-35 detects the retaliatory launch, while a Patriot intercepts the missile, while a Lucas swarm suppresses the next launcher, while HIMARS destroys the command node directing the response. All within minutes, all coordinated through data links that didn't exist a decade ago. The 1991 Arsenal was a collection of weapons. The 2026 Arsenal is a system. That transformation, from collection to system, is the single most important evolution in American military capability since stealth. The weapons haven't just gotten better. They've learned to talk to each other. And that conversation is about to get faster than any human can follow. By 2030, the Collaborative Combat Aircraft Program adds autonomous drone wingmen to this network. AI-controlled jets alongside F-35s, making tactical decisions without human input. By 2035, directed energy weapons standard on every surface combatant. Cheap threats eliminated for dollars instead of millions. By 2040, the weapons won't just communicate. They will coordinate autonomously, selecting targets, assigning shooters, executing strikes at machine speed. The human operator becomes a supervisor, then an observer, then, perhaps, unnecessary. The Arsenal of 2026 is the last generation where humans make every decision. What comes next is a battlefield where machines propose and humans approve, until the battle moves too fast for approval and the machines simply act. But the most lethal arsenal ever assembled has a blind spot. One that no Tomahawk can fix, no THAAD can intercept, and no laser can burn through. It is not a weapon. It is a science, born from a forgotten mathematical paper written in the Soviet Union in 1962, a paper that proved any shape could be made invisible to radar if its surfaces were angled precisely enough. That paper was ignored by Moscow. It was found by Lockheed Martin, and it produced the technology that makes the B-2 a ghost, the F-35 a phantom, and the next generation of warfare something radar cannot touch. Next week, Exodus reveals the complete evolution of stealth, from a Soviet equation to the 6th-generation fighter that no sensor on Earth can find. Subscribe now so the full chronology is waiting the moment it drops. On February 28, 2026, the United States launched the most diverse arsenal ever deployed in a single operation. Some weapons designed during the Cold War, some built last year. One copied from the enemy it is now being used against, from a $1.5 million cruise missile designed in 1980 to a $35,000 drone designed in 2024. From a $4 billion stealth bomber visible only as a pigeon on radar to a laser that costs $10 to fire. The evolution of America's arsenal didn't happen in a straight line. It happened in 35 years of parallel transformations, each weapon following its own path, until March 2026 brought them all together on a single battlefield for the first time. The result is not just an arsenal. It is the most complex integration of military technology ever attempted by any nation in history. And it is happening right now. This is Exodus, how everything transforms.